Hello, everyone. Welcome. And I'm really excited to be here. This is my first time. So I'm a little bit nervous, but then let's carry on. I am Abhi. I'm a product manager for the enterprise business unit in Cisco. And I'm here to talk to you about Catalyst 9000 UPOE Plus, which is also IEEE 802.3 90 watt. And often I get asked this question, why do we need 90 watt over Ethernet? Now, the same question was asked about 2 decades ago. And that's when Cisco had to build PoE for IP telephony. IP telephony required the same seamless experience where there would be one cable for power and connectivity. And 20 years down the road, PoE has evolved significantly. Now, before I go any further, I just want to quickly talk about 3 main terminologies that I'll be frequently using during our presentation. One is a PAC, which is a power source equipment, which essentially is the power supply, if you will. A PD, which is a power device, which is the endpoint that draws power from the PAC. And a pair set is essentially a pair of strands that form a category cable. So a category cable has 4 pairs, and a pair set is a couple of those pair strands that stand for a pair set. Now, fundamentally, the principles of, or the guarantees that PoE used to provide hasn't changed. Most importantly, the safety aspect still remains, which is a PAC would not provide power until it detected a legitimate power device. Right? It uses a 10-volt of detection mechanism, which is safe for any device, and it is safe for humans to touch. And for every PD, there has to be a unique 25 kilo ohms resistance that has to be implemented for a PD to be a legitimate power device. The other principle is that there has to be a negotiation preceding the power draw. So before a PAC starts providing power, both the PD and the PACs have to negotiate and agree on the maximum power that can be drawn from the PD and the maximum power that the PAC can source. And this is done with a voltage range of 15.5 to 20 volts, which is, again, pretty safe for the human to touch. Now, pre-802.3 BT standard, the classification was done entirely in layer 1. And the next phase would be the request for power, and that would require a higher layer protocol, which was LLDP and CDP. Now, going forward, 802.3 BT does not require a higher layer protocol. So it's a much faster convergence between the PD and the PAC to start drawing power.
So it's a straight physical negotiation.
Just a straight
you just let the electrical signal what the
that is
2
correct.
sides can do. Okay.
That is correct. Now, the third step, of course, and the third principle is the actual power draw. The actual power draw before the BT standard, which is the 802.3 AT and the 802.3 AF standards, would happen over a pair set, which is 2 pairs of strands. And that would essentially limit the power draw to 45 watts. Now, in order to increase the power drawn over the same category 5 cable, 4 pairs were started to be used from the UPOE times onward. So Cisco UPOE and 802.3 BT use both pair sets to be able to drive up to 90 watts of power. Now, this fundamental aspect, which is safety, still remains intact with PoE. And this is essentially because PoE is conforms to ISO IEC 60950, which essentially guarantees that the maximum voltage would not exceed 60 volts DC, and the maximum power would not exceed 100 watts. So this essentially are limits which are safe for devices that are within the proximity of humans. Now, this essentially allows IT and OT teams to be able to deploy PoE up to 90 watts very easily across their premises without the help of or without the need for any electrical technicians. Now, before BT was there, there were 4 different classes of devices which could draw up to 30 watts of power. And they essentially formed the 2 types, type 1 and type 2. And then we required, back in Cisco, we required to power compact switches, which required higher power than 30 watts. So we developed UPOE, which is a proprietary method of delivering 60 watts of power. And then 802.3bt happened, which introduced 4 new classes for power devices. And the beauty of 802.3bt is that the type 3 actually allows a backward compatibility across all devices that are around today. Right? So BT ensures backward compatibility and also allows you to expand the ecosystem with 4 new classes of power devices. Now, a power device, obviously, for the benefits that 802.3bt provides, it makes a lot of sense for PDs to start implementing BT. Even PDs that do not will continue to be supported with BT-compliant PSEs. And PDs that actually support BT can choose between type 3 or class up to class 6 or type 4 up to class 8. The dual signature mechanism in the standard allows PDs to function or work with both PSEs that are type 3 and type 4.
Okay.
Now, what does BT bring to the table? BT essentially expands the ecosystem with 4 new classes. BT provides to 200% higher power, which allows you to draw 90 watts on the same category 5 cable. BT ensures the safety standards that were established with PoE and improves upon it by providing something called connection check, which checks the connection or the transmission of the cable as well before it starts sending power across both pair sets. And BT provides or facilitates PoE to be delivered alongside higher speeds, higher than 1 gig, which is up to 10 gigabits per second. And finally, energy savings, which is a significant requirement from an IoT or an OT deployment. BT ensures that there is power delivery is more efficient because it's 50% more efficient to deliver power over 2 pair sets than compared to the previous standards.
Because you're transferring less current per pair.
That's correct.
So you're getting less current loss per.
That is right.
Yeah, right.
And finally, the amount of time the power device needs to be awake has significantly reduced. So the power devices like lights can actually go to sleep longer without going offline. So that's a significant step towards higher energy savings. Now, with all of these benefits that BT brings, brand new architectures are emerging with PoE. The first one is the USB-C standard, which allows you to drive power and up to 5 gigabits per second of connectivity using the USB-C standard. The second architecture that's evolving is extending higher power for longer distances. As you know, PoE is restricted by the distance of copper, which is about 100 meters. But now if you have an extender PoE switch, you can extend that distance. Not only that, with 90 watts of power, you can actually, we are able to actually extend more power to the endpoints from that extender switch. And the third architecture that's emerging is daisy chaining. Now, by virtue of the fact that you have more power per port, you can actually connect many power devices in a daisy chain manner and be able to drive much better cost per watt. Now, when I came in here, I had to carry this power brick with me. But with the high performance environments that we are seeing today in enterprises, worker mobility is significantly important. No worker wants to be restricted to their desk anymore. But they have the problem of having to carry a power brick everywhere they go with so many different connectors and so many different power brick options. But USB-C is changing all of that. And more vendors are bringing USB-C across their devices, tablets, laptops, smartphones. Now with that, and the capability that we have with power over Ethernet, you can actually allow workers to freely, flexibly move across their workspaces, desktop, conference room, meeting rooms, lobbies, to even cafeterias, without having to carry their power brick along everywhere. And this is by virtue of the USB-C dongle, which combines power and high-speed data into a single device. So I have this prototype with me, which I brought along. And hopefully, when we meet next time, we will only see these in these rooms and not having to carry the power brick. So you can pass this along and feel free to take a look at it. So this brings in tremendous flexibility from a BYOD point of view. So you do not have to be stuck to a particular device manufacturer. And also reduces the cost because now you have a single cable for both power and data.
So you're pushing 90 watts out of a PoE, typical laptop, 60 watts.
That's right.
60 watt charger. So you've even got so even a bigger, like a MacBook Pro type thing, which is pulling what, 70 watts, 75 watt chargers?
75 watts.
Yeah.
So that would be a class 8 device,
yeah,
which would get about 75 watts of power.
So you can pretty much power any sort of modern laptop.
Laptops, tablets, smartphones. And essentially, the cost saving is significantly high. You don't have to have so many AC outlets out there in those tiny conference rooms. Now, it's not only the IT, it's the OT space as well, which is seeing a significant revolution with PoE. Now, PoE is not new to the OT workspace, the OT space landscape. That's because there have been devices like access points, lights, that have been powered in the past. Now, if you look at these industry verticals, starting to look at how the hospitality vertical has emerged with 90 watt being available, devices that were until recently, not even considered to be powered using PoE can be powered with PoE. The mini bars, smart mirrors, window shades, HVAC, all of these can actually be now powered using PoE in the same room. So that significantly improves the guest experience. So all of your hotel rooms are now connected, smart, and also they can realize significant amount of energy savings. Healthcare industries have always used switching for connecting biomedical devices. Now they can expand that footprint significantly. Retail experience is one of the most critical needs of retail industry today. How do they evolve the user experience or the buyer experience? With all of these connected devices like large screen, high resolution displays, BLE or Bluetooth enabled access points that require to draw more power, and also having people counting sensors to understand where people are and send the people to those areas to help them. So the whole experience that shoppers have in the retail industry is significantly pivoting on connected environments. And that is going to be completely transformed with PoE in the retail industry. Now, what is Cisco doing to get all of this enabled across the verticals? So we are working with ecosystem partners across the board to build solutions together. The USB-C dongle is one example, and we are working with many name brands like Panasonic for cameras, Thin Labs for all-in-one computers and PoE displays. And we have name brands in lighting as well, like Molex and Igor, who we are actively working with.
So can I just ask a quick question? Differentiating Ethernet patch leads versus USB patch leads, is there a physical benefit of Ethernet cables over USB cables? Because everybody's used to, the challenge that I can see is that many people are familiar with the USB-C cable and would expect to plug in to a USB. And the Ethernet thing's that's not what everybody knows. I'm talking about consumers or normal people.
That's right.
Yeah, so...
I think I understand your question. So essentially, the USB-C dongle is not something that you carry along with yourself.
Yeah.
It's just plugged into the Ethernet port.
It's available on every desk.
Every room, and you just go in and tap into it for power and data.
It needs a wireless charger for smartphones on top, actually.
So
it should have a little wireless charge, little.
That's a very good idea. I mean,
Does it just,
No, but I missed the and so you want to power everything via Ethernet, but actually I need my power supply anyway because I travel. So I'm on a train, for example. I won't have your switch, so my power supply is necessary anyway. So in my backpack, and I run via Wi-Fi with this device. So. And it's crazy expensive. I mean, I have to buy your switch just to have power. Mm-hmm. And maybe you are saying also light bulbs or other things. Connecting a light bulb with a standard electric connection is, very, very inexpensive. Why should I connect the light bulb with an Ethernet cable?
Very good question. So the USB-C, first of all, coming to the first question, the USB-C dongle that we see here is not a personal adapter. It's more for adapter that goes into every room, every conference, every desk, which is for an enterprise environment, right? You're right, when you travel, obviously you do not have Ethernet port in the train. You don't have Ethernet port. Probably in the hotels, of course, you do, but they may not have PoE on those ports. But for a personal device, it still will be a power brick. But for an enterprise, you can eliminate the whole hassle of carrying a power brick along and make it much more flexible.
I'm missing something here, and please, if
I'm the same guy that was traveling the night before the hotel, so
guy carrying 3 tons of cables.
I still have the power supply in my backpack. So
yeah, for traveling, obviously, for a personal charging requirement, you would have to carry the power brick. But then, for example, I wouldn't have to travel from my building in building 22 to building 10 with a power brick. And if I had forgotten, I would have an anxiety all the time that what if my laptop runs out of power?
what's the difference between placing the USB-C PoE adapter versus just placing a USB-C power brick like we use on our laptop? There's already outlets in every room we possibly ever go to. So this isn't solving a problem that I actually see. Like I'm trying to understand, like if a building or if a company wanted to provide power, USB-C power for every possible place you could possibly work, we could do that today.
Correct. For a building like Cisco, yes, because they have built so many AC outlets already. But imagine your building are revamping a very old building where you would have to lay out conduits for AC everywhere. You can save that time and significantly leverage because there is copper cabling, Ethernet cabling everywhere for data now. You can leverage the same Ethernet cable for both power and data.
I have not seen a room that has more Ethernet than...
And there are so many historical buildings you can't touch anything. The only thing that you can do is put Wi-Fi and rely on what it's there for, built 100 years ago. So they don't give you any permission to build, a new network, if it goes that way, okay.
Essentially, there's a subtle difference between AC cabling and Ethernet cabling. Ethernet cabling can actually run through the rooftops, where you can actually hang them. But AC conduits have to be built within the wall, which is quite, invasive, right? Which is exactly the reason. Now there is a hotel in Texas that has been remodeled, and that is completely PoE powered, and that's entirely the reason why they could not touch that historic building to lay out new conduits. They are using copper cables, Ethernet cables to actually deliver power and data.
So I have a question about the data piece of this, right? So what I'm thinking also happens is because this is it's for IoT devices, you're able to send data back from them. So with the light bulb example and a hotel example, I can tell exactly where. If something goes out, if nobody's in a wing, I can easily turn it off. If I have the rewards cards, I know when people are coming in and out, I can help automatically do the light, all of that. If that's the case, then what kind of vulnerabilities does a device, those kind of devices have, especially one where I plug my own laptop into the data just to get power? What kind of vulnerabilities does that introduce?
You have raised a very important question, and that's exactly what I'm going to talk about on my next slide.
Okay.
But before that, I wanted to answer the lighting question. And the lighting question was around, I think, why would lights use Ethernet? And that's exactly, I think, she just gave us a very good pointer right there, where connected lights save a lot more power. And there are legislations across the United States now to save energy, starting with New York City. And there are deadlines to save energy within a period of or a block of years. And it is seen that with smart lighting, you can actually enable a lot more savings with smart power shades that come down and save air cooling costs. You significantly save energy. So with all of this connected environment, the energy savings are significantly higher. So that's why connected smart lighting. Now, any more questions? Because the security question seems to be the most prominent question that keeps coming up. Like with so many devices that are connecting into your network now, what happens to your security posture, especially for an enterprise, a financial stockbroking organization, a hospital which maintains confidential medical records? And that's the most important question that needs to be answered. Yes, we get smart lighting, we get energy savings, but at the same time, there cannot be any compromise on the security. Now, in the past, the IT and the OT networks were very fragmented. They were managed by separate teams. And as a result, they were still connected to the same access infrastructure, but not monitored as well they should have been. And recently there was a large international retail chain which was impacted by a security breach which happened from the HVAC units. And that resulted in a lot of financial information getting stolen. Now that is where Cisco's endgame is, to enable all of these endpoints to connect to the same network, however, be able to provide a very, very strict, trust-centric onboarding. So every device is monitored and made sure that it is trusted and then onboarded. And then provide a very solid segmentation, which allows you to segment your network very, very securely. Third is to be able to provide a trust-centric monitoring piece, which essentially allows you to monitor the activity or the data that is sent out from all of these devices. And finally, be able to allow a consistent policy that resides within your enterprise across your enterprise IT as well as OT, and be able to enforce that across all of these devices, right? So that is the Cisco vision that we have with all of the devices connecting to an IT and OT network convergence use case.